Hello everyone, in this video I'll be explaining the solution of problem D from CodeForces around 096 div3. If you want to see more content like this, please like and subscribe. We are close to 500. Yusef has given you an array of 2 times n integers. Every integer is between 0 and n minus 1 and appears exactly twice in the array. Remember this because it will help us in the future. Your task is to find a subarray that is a palindrome such that MEX is maximized. Outputs this maximum possible value. MEX is an array of integers. The MEX of an array of integers is defined as the smallest non-negative integer which does not occur in the array. So, for example, if we have this array, MEX is equal to 2 because 0 appears, 1 appears, 3 appears, and 5 appears. And 2 is the smallest non-negative number that doesn't appear here. Okay, so the problem, well, let's understand the problem first. So if you have this example, so you have this array. Our goal is to determine the subarray that's whose MEX is the maximum value, has the maximum value. In this example, and the subarray must be a palindrome. In this example, we can the entire array is a palindrome. So if you start here, this is an even length palindrome. The MEX of this array is equal to 4. Okay. The first key observation is that the minimum answer to this problem is always 1, because we know that the elements of the array, in the elements of the array, 0 always appears. So, for example, if we have some array, we can take 0 as an individual subarray, and the MEX will be 1. So that means that an optimal array, a bigger and longer palindrome, a subarray with a MEX greater than 1, always contains 0. Because of that, the problem becomes very simple. We know that 0 appears exactly twice in the array. So the solution starts like this. If we know where both zeros appear, so for example, let's take this one, or no, this one. We know that the first 0 appears at index 1, and the second 0 appears at index 4. We can we have 3 cases. So because every optimal answer must contain 0 and it's a palindrome, we can try to form these subarrays like this, with one subarray with x being in the middle of the palindrome. So from this 0 we could have go like this and like this, but this is the palindrome. Then we can start from y as the middle of the palindrome. So if we go here, this will be the middle of our palindrome, and we can start to expand the subarray. So in the beginning it's here, then we can I will be here, and we know they're equal, so it's still a palindrome. And then we move I further to the left, J further to the right, and this is still a palindrome, but then we can't expand it. So this will be a good subarray. And from here we can find the MEX pretty simple. But there are one more case. If 0 and 0 appear in a palindrome, but they are not centers. For example, if we had something like this, like so 0, the entire array is a palindrome, but zeros are not centers. So we can try all of these cases one time with x being the center of one subarray, y being the center of one subarray, and the zeros to be part of a palindrome, both of them. And we can start, so if you know x and y, we can create a function, expand, that takes 2 indices, the left and right. So if it's an even length palindrome, this will be like I and I plus 1. But if it's odd length of palindrome, it will be like this, so the center will be 1. But for example, if we had like 2, 3, 3, 2, this will be I and j. And if we try to, if you compare all of those answers after finding the MEX for all of them, we will get our solution, our best solution in O of n. Okay, so now let's take a look at the implementation using what we've discussed. So we have to get the first occurrence and second occurrence of the number 0. And now I have to try all of the possibilities. So let's say A, where A is the first, so no, X center, X will be the center. I will be the center. And then we have even and odd palindromes. And I can have write a function called expand or solve or whatever you want to call it. That will take our I and j indices or left and right, and return us the MEX of the maximum possible palindrome starting from that center. So we have right is less or equal to 2 times n because we have an array of 2 times n integers. And because the palindrome, this should be equal. And we have left plus. So then we can delete, erase the current element from our MEX. And because we keep a set, the smallest element that didn't appear in our subarray will be at the first position. And now you can get those values. So expand and for even, expand will look like this. This will be for even length palindromes. This will be for odd length palindromes where the center, well, left and right are the same. And we can make a variable result that will be the MEX. I have to add this. If it compiles, what did I do? Sorry. For two. Okay. That's the problem. 4, 2, 1. Perfect. Now let's try to submit the code. Why? Yes. Thank you for watching. If you find this video helpful, please like and subscribe. Leave a comment if you didn't quite understand my explanation. And subscribe because I'm so close to 500 subscribers. Thank you for the support until now.